What's up, Internet? We're assembling the short block for the Chevy 350, and one of the very important things you need to do when you are assembling a short block that's brand new is setting the ring end gap. So let's talk about that. Okay, so here you can see a piston ring. Now generally engines, or most passenger car engines, are going to have 3 sets of rings. You can see I got a piston here. You're going to have the bottom set, which consists of 3 parts, which is the separator, the kind of wavy part, and then 2 small. This is your oil control ring. And then you're going to have 2 grooves. You're going to have 2 compression rings. So the basic job of these is to help seal the cylinder, because these pistons, there's some clearance between them, and when you have the flame front, it can go past the edge of the piston. Well, these rings will help seal that, and then the oil control ring will help scrape any excess oil off the side of the cylinder walls. So most rings, as far as in a performance setting, are going to have a certain gap to them, and it's going to vary depending on bore, piston material, and anything like that. Okay, so here it kind of tells you about your ring end gap, and it kind of gives you all the basic information. So depending, street strip, circle track, forced induction, and then the top ring, second ring, and the type of piston material we're using. So for me, I have a hyper-eutectic piston. My bore is a 4.030. So I'd multiply that by 0.0065, which gives me about 26 thousandths for the top. And then for the second ring, I'm setting it right around at 20. And you're going, how do I set that? Well, let me show you. Okay, so we got the bore of our cylinder, and when you set these up, you want the rings to stay in orientation of the bore. And what I mean by that is, when you measure this and this would be number 4 on this block, so 2-4, you want this to go on the number 4 piston, because the bores can all have a slight tolerance difference. And then you're also going to look and you're going to see right here on this ring, it says top, so you know that's going to go up. So the easiest way to do this is you're going to push it in sideways and then rotate it. And then you're going to want to make sure that's even in there. I'm using a piston squaring tool, just like that. Make sure that it's down in the bore far enough, and then that creates a gap, and you can see right there. Now I'll take my 20 thousandths gap on a feeler gauge, and I will try to fit that in there, and it won't fit. So that means I've got to shave some material off the sides of that to make that gap big enough. And the reason you want to do that is with the pistons and the rings, as they heat up, heat causes things to expand. So with that close of a gap, it can get tighter and tighter together, and those can touch. Well, when they're inside of the lands of a piston, those grooves that I showed you where the piston rings were in, when they touch, they can't go anywhere. So they'll want to push out like that, and that'll break a piston. So we need to file that. So here I've got a piston ring filer. This is just a cheap one off of Amazon, and it's got holes in it where you can like screw it to a table. I didn't want that, so I just took a piece of angle iron, drilled the holes, and just mounted it. And I had to mount it offset so this handle wouldn't hit my vise. But I like to keep the orientation proper, and then you're going to take the top and you're going to want to square this flat with this blade. And you can do it on either side. I'll use this as a stop. Make sure that this is parallel to it flat. And run it. And then I will look and make sure that I have a nice clean surface all the way around. And you don't want to go crazy with this, because you can actually take off quite a bit of material. I mean, just those few turns is probably all I'm gonna need. Okay, with that filed, We will try this again. Get that down in there. Square it up. And get back to my 20 thousandths. And still a little tight. So it's just starting to go in there, but you want it to be able to slip in and have a little bit of drag. So I got to file this a little bit more. Okay, I filed it some more. Back with my 20 thousandths, and you can see it fits in there, but it's got drag to it. So that means it's nice and right on that measurement. So you just have to do that for every single bore for the top ring and the second ring. I'm doing the second ring, kind of working my way up from the bottom. And once I get the gap set, I put the ring on the piston. Now there is a spec for how much distance you can get on the oil control rings. I put all those in and make sure it was at the minimum. That way it was good. So let's take this out and put the ring on the piston. So I've got my piston, and then grab my ring. Again, make sure you orient it. Like I said, it says top on there. Make sure you put that towards the top. Now some people will just kind of spiral these on there. These rings, they're not any high performance. They're more of a stock replacement ring. So they're a little bit heavier. So I'm using a set of piston ring pliers. They got these tapered grooves in them that grip the end of the ring like that. And as you squeeze it, it expands it. So you can just kind of go over. Now you don't want to go crazy and just He-Man these as wide as you can, because these rings can be brittle. And you try to expand them too much, they will break on you. And I've got this one partially stuck in the top groove here. So let's get that out. Just like that. It's in there, and it's gonna have some movement because it still has to compress. So you want that nice tight fit for when you put the piston back in there. And then of course, I'm keeping my pistons organized so I know which piston goes in what bore with the rings that I measured. And you can see I got my pistons set up in the box that came in. I already assembled the rods, but you can see I got a mark 2468 and then 1357 on the other side. That way everything is organized, then everything's going together the way it needs to. So as you can see, it's kind of a tedious job, but it's really important. Again, if those gaps are too tight, the heat will cause it to break the piston, cause scuffing and everything inside the cylinder wall. So you want to take your time doing it. That's why it costs money for people to build engines. Some rings, you might put it in there and all the gaps are just fine. You don't ever have to set anything. These ones, I'm having to file on each one. But that's kind of what we're doing. Like I said, every engine's different, and your ring manufacturer will normally send that sheet like I showed you, so you know which rings go where and how to do that. So, till next time.